So welcome everybody to the workshop of Simple Cloudstack Deployment with KVM. We will start the third day of our conference. Actually, it's the fourth day of the conference with a workshop delivered by Andrea Panik, who is a cloud engineer and architect from Sheibu. Hi, Andrea.
Hi, Beth. Thanks for introducing me. All right, good. We have 1 hour, which is pretty tight to cover everything, but we should be good. So I'm probably going to actually start right now. So the aim of this workshop is to show how easy it is to effectively deploy Cloudstack on 2 hosts once you have all the input parameters for the networking and everything else. I will also show how to configure the networking side on the KVM hosts or bridges and so on. We'll show a little bit of diagrams about our networking, basically background or physical networking, if you like, and basically lay out all the steps needed to do so. So yeah, let's actually get going. So this is going to be a very simple deployment with only 3 servers. In my environment, I'm actually using the nested virtualization, so these are actually virtual components, but it's absolutely the same what you can do in reality or let's say with the physical stuff. We have 2 KVM hosts and 1 additional host, which will be effectively our Cloudstack management and Mysql server, while the primary and secondary storage are based on NFS. They are remote on already existing NFS servers, so we will not be installing NFS here. How it actually looks in the background. So let me get my fancy laser point here with PowerPoint. So we have 1, let's say, physical switch in our case, or it could be simply a group of ports on a single switch. Doesn't have to be 2 separate switches, but there is 1 VLAN or network which we call management network, to which all the components, all the servers are connected, including primary and secondary storage NFS. We are not using what's known as storage traffic network as an explicitly configured thing. We are not using it, so it implicitly flows over the management network. So there is only a management network, and then we have a separate switch, or in your case, it might be simply a separate set of physical switch ports on a different VLANs. Those ports need to be configured in a trunk. I'm going to lay down later all the input details for pod and public network configuration and so on. But here you can see that we have a red VLAN, red colored VLAN. I just put it here so it actually stands out a bit. We're using VLAN 51 in Cloudstack. This will serve as a public network. And then we have a bunch of the other guest VLANs or VLANs that will be actually used for the tenant networking. So your ports need to be configured in a trunked mode to support these VLANs 51 and in my case 21 until 1540. So this is a very simple thing. Now, if you refer to the Cloudstack documentation, you might have seen a picture similar to this one. So again, just to clarify, we have 1 cluster with 2 KVM hosts with a primary NFS storage. Again, this is a remote already existing NFS export or NFS share. And we are having a secondary storage. You can see it's actually on the same server for that matter. We have our management and Mysql or database server. And this whole pod is actually in a zone. We have only 1 pod in a zone, so that's the reason I put it over here. We have certain IP ranges over here. You don't need to obviously remember any of these. I'm just laying down the components. So these let's say physical resources, servers and primary storage, primary secondary storage, they are inside the same subnet. You can see 10.032.0/20. So these ones and this range over here, system reserve, these are all inside this single subnet. This is quite large subnet, actually. It's /20, not /24. And system reserve start IPs and system reserve end IPs that's a small IP range that we will give to CloudStack, from which CloudStack will assign IP addresses for the management interfaces of the system VMs. So secondary storage VM, console proxy VM in our case, and that's it. This is the pod, the management traffic info for the pod. We have similar for the public one. So again, we have a quite large /20 network, but we are using a smaller subset of only 20 IPs, and we are using VLAN 51. So in the previous diagram, and finally, when it comes to the guest traffic info, which is always on the zone level, these VLANs span the whole zone. We are using this small IP, well, not IP, sorry, VLAN range of only 20 VLANs, which we will assign to the zone, and then CloudStack will create tenant networks from these VLANs, effectively using each VLAN for a separate network. Now, these are some of the input things. Let's go to the high-level steps, and I am actually going to execute all of the required steps in front of you so that you can actually see. To prepare the operating system, SC Linux set to permissive disable, NTP or time synchronization in general should be working perfectly fine between all the components in the management plane. Host name, full host name should return actually a full host name, not a short version, just the host name. Then in words, we don't actually need to install explicit MySQL. So some of these steps I have cross-lined, they were in the guide, and they are actually still in the guide. We need to update this one. Set repo, install the CloudStack management and usage, basically binaries from this repo. This will pull all the depending Java 11. So if you are having some other version of Java, you need to make sure this is set as the default one. You'll see as we go forward. We will install MySQL and do the very minimal basic configuration of the mysql.conf for CloudStack. No tuning, no serious production setup, nothing. This will be really just very basically yum install and adding things and starting MySQL. So this is obviously outside of the scope, any kind of tuning for production. And finally, we are going to set up databases, which will load the initial versions of CloudStack databases into, or content of the CloudStack databases into the actual cloud database. And finally, run the CloudStack setup management, which will do a bit of firewall configuration and start the server. This is basically the management server and MySQL actually server deployment methodology in high level. And also let's quickly cover KVM host deployment methodology. So basically we're going to again prepare the operating system, ensure time synchronization is there, host name, SC Linux, again Java 11. It will be actually pulled in automatically as a dependency when you install agent. I think I missed here to add that we need to create a repo, which we obviously do. Have to do, and at the very end we will actually do the network bridges configuration. I'm going to actually show you some hopefully interesting diagrams for that one. So that being said, let me pull up my notes on a second screen so I have my inputs ready. I'm going to now actually do a split screen if that's okay. So this is my terminal over here. And I'm going to open the quick installation guide. Now, a couple of words of warning. I'm using the quick installation guide not as something that I will blindly follow, because this is installing everything in a single box and usable in sense of anywhere near to production. But I'm actually using the quick install guide just to copy paste commands that I need as literally as a reference. There is a reason why I didn't prepare the commands and show you my notes. I wanted to show you how to do it through the quick installation guide. That's the reason. So let's first start with the management server. We can scroll through the menu of the things. We This one is actually done for the bridge utils, and it's actually done on the KVM host, but I will install it anyway on management server as well. And in the background you can see actually it's being installed. Now the networking configuration I want to leave for the end, and this is applicable only for KVM hosts. I'm now doing my management server, no networking, no special networking configuration there, nothing, right? So I'm not going to do any of these. We need to ensure host name is actually providing or returning a full long version of the host name. You can see there is server.subdomain.domain.com, so that's all good. SE Linux, we want to check by default get enforce command will show it's set to enforcing. I will set it to 0. I will quickly edit just to show you the location, even though for the purpose of this lab I don't actually, but this is something you would want to do and set it permanently to either permissive or disabled, depending on your corporate policies. So if I now repeat, oops, what did I do? Okay, let me just confirm it's set to permissive. That's good. Right, if I now repeat, the get enforce, it's showing as permissive, so I'm good to go. NTP. So I'm personally going to skip this step for a simple reason that these are nested VMs in my case, and my time synchronization is done based on the real physical hypervisors via VMware tools. So that's the reason. But other than that, you do need to ensure either NTP mechanism is there to make sure that the time between all your hosts is actually properly synchronized. So I'm going to skip that one. As I said, this is only me being able to do it in my own setup because it's a nested thing. I'm going to create the CloudStack repo with CloudStack 4.15, which is something we are going to install. I'm going to save the file and exit. NFS utils just for the client side utils. We are going client side NFS. Actually, we are going to install NFS utils. Otherwise, we are not configuring an NFS server. As I said, we have already a remote server. So all the steps for making the exports and doing configuration and things like that, I'm going to skip. In my case, I'm not using NFS version 4, so I don't need to actually go through different things and configure as in the guide. I'm using version 3. There are reasons why we are using version 3 because of some older clients as well. So again, I'm personally skipping the whole NFS setup because it's version 3 and my NFS server is already up and running remotely. Firewall, if you actually check the firewall, you are now doing new builds. There is tons of ports being used. My really good suggestion is to actually disable firewall initially, so you avoid all the issues you might have because of a misconfigured firewall. And then when you have everything up and running, do your homework, learn your ports being used everywhere, and then slowly start implementing firewall. So I'm going to just say systemctl stop firewall D, but it will basically show that it's not even loaded. In my VMs, it's already disabled. And I can continue with actually installing my Mysql server. So I'm going to bluntly copy paste everything from the guide. This will install not the latest, but it will install Mysql 5.6. So I'm now just installing the repo. We could do it obviously in a quicker way than with 3 commands. And finally, after I have my repo installed for the Mysql community server, I'm going to say yum install mysql-server, and this will pull in certain dependencies. After that's done, and it takes a bit of time, we can go into actually configuring the Mysql configuration file, adding a couple of lines that are actually required for proper functioning of CloudStack in a long term. So let's give this a couple of more seconds, and we are All right, that's good. So I'm going to, sorry for that. I'm going to edit my /etc my.cnf. This is the MySQL configuration file on Linux, on Linux on CentOS, right? So I'm going to find MySQL D section, which is over here, and I'm just going to add those couple of lines to my section that starts with MySQL D. I'm going to exit the file, save the changes. I'm going to enable my daemon, or starting actually MySQL on boot, and I'm actually going to start it just now. Right, a letter missing there. Let's give it a second or two. While this is starting, as I mentioned in the slide, we are going to skip installing MySQL connector, Python connector, MySQL, because it's no longer required. And also historically, MySQL Java connector was also required. It's also no more required. It's bundled with CloudStack Management Server. So this is something we can skip. This part, we obviously need to update to simply remove this from the 4.15 version of the installation guide. If I hit MySQL and hit enter, you will see I can log in, I can show my databases. There is no custom database, it's all system databases over there, so that's all good. Finally, we have our database server configured and running with a very minimal configuration, as far from production ready as it can be, obviously. But now that I have my database server running and I have my CloudStack repository set, I will install management server. It takes a little bit of time, but you can see that it's after installing CloudStack, well, during installation of the CloudStack management server, it will pull in the CloudStack commons, the dependency, and then many other things like Python 3. Where is it? Java 11 should also be pulled in. Here we go. Java 11 is also installed, so all the required dependencies will be automatically installed. So let's give this a couple of seconds. And after this is done, we are going to confirm, just in case you maybe have some other Java version as well already installed, you need to confirm or configure Java 11 to be the default one, because that's what's used by CloudStack. The installation of the management server and all the required dependency packages is finished. So I'm just going to basically run the alternatives --config Java. It is indeed telling me I have only one version of Java. It's already set as the default one, so I was going to cancel out with my Control-C. And now it's time for us to load initial CloudStack databases into the database server, and to also create MySQL cloud user with the password for that user. As you can see, I'm using all the defaults. Obviously, in production, you would use something very complex. You would additionally specify key, database encryption key, and management server key, but this is the bare minimum that you need to do. And when I hit enter, effectively, it will create the cloud user, the password for that user. It will load the databases, which you can see over here, and you should get the message CloudStack has successfully initialized the databases. Also, the file db.properties over here is created. It actually contains information about the actual cloud database, the MySQL host, the IP of the management server, which is also referenced over here, as well as the database login credentials and ports and things like that. So everything is here in the db.properties. Finally, I'm going, or almost finally, actually, I'm going to do the CloudStack setup management command, which will actually ensure certain things are in place system-wide, and it will configure IP table rules actually it will not configure IP table rules. That's something we also removed in the later versions, simply because if you run this on Ubuntu, a different thing, different kind of firewall is used if you write on CentOS 6, CentOS 7, Firewall D versus basic IP tables. So if you actually check my IP tables, I have pretty much nothing over there, no firewall, and we do now just echo the message that you need to ensure that a certain TCP ports are open, whatever kind of local firewall you might be using, because it was really impossible to support all kind of firewalls on different type of Linux distributions. So this was a safe way to go with a proper message. Right, so this command will also start the management server. And while it's starting, we do need to actually in the system VM template to our secondary storage. So I'm basically going to first create the mount point that is just used temporarily to basically be able to secondary storage. And now I'm going to actually use the mount command to mount, oops, sorry for that, to mount my NFS from the existing NFS share remote. Right, sorry, I didn't put the mount point as it seems. You do need to obviously specify where you're mounting it. So if you check over now, I have my NFS mounted on the /expert secondary. I'm going to use now, after I paste it, I'm going to use a script. So just a second. I'm going to use a script which does the installation. So this is the path of the script. We are specifying the temporarily configured mount point of our secondary storage. And we are telling CloudStack to go and download this specific template. You can see it's a format for the KVM hypervisor. So when I hit enter, CloudStack will download it. It takes some time and it will also extract it. And that's pretty much it. So our system VM template will be ready to go. This is taking some time, so I'm not going to wait for this. I'm going to continue with my KVM host setup. So if we continue to the KVM setup installation, we need to do a couple of things. I have 2 KVM hosts. I'm just going to do things in parallel, if you don't mind. We have to configure the networking, which is something I want to leave for the end. We need to do our hostname thing. So hostname -f should be returning our fully qualified host name, and basically it is working fine. We want to configure SC Linux, so I'm going to say set enforce 0. This is lab. In my case, I don't care to actually go and make this change permanent because I'm going to destroy my lab afterwards. But as you could see on the management server, you do need to make that change permanently. Again, NTP step I'm skipping because my hypervisor hosts are nested and synchronized via VMware tools with the management server, which is actually synchronized with the hypervisor as well as these two. So that's already all good. I'm going to now configure a repository file. I'm going to briefly scroll up and create my CloudStack repo file. I'm doing it in parallel on both hosts, so we don't need to be repeating those steps many times. I'm going to copy the content, obviously. Exit the file, save the changes, copy the content, exit the file, save the changes. Going back to my KVM host section, I'm obviously now done with some things except configuring the network. That's something we are going to leave for the end. I want to show you some diagrams related to this. We do need to install Apple release because of a package dependency, which is unfortunately not available in the basic CentOS repos. So let's give this a second. It's already installed on both hosts. And now finally, I'm going to install a CloudStack agent. Now this will pull in a lot of dependencies. I'm going to show you now. You will notice I never said yum install Kemu or libvirt or so on, because this is already a requirement or dependency from You see, I have only wanted to install agent, but it will pull in CloudStack common package, all the different libraries as needed, Java 11, which I need, libvirt version 4.5.0 from the default repos. You can later upgrade this if you want with a custom versions, if that's something you use. NFS utils is also used, so I can actually skip it. And here we go, Python 3 as well, QEMU image, KVM command, those are all pulled in. One of these packages from the EPEL repo, I'm just searching for it as we speak, is that was Python 36. Here we go. This is the only one pulled from the EPEL repo, just for the sake of showing that this was a requirement. That's why we have added the EPEL repo on CentOS. Now it's almost done on both hosts. I'm going to just scroll a bit aggressively, if that's correct terminology. So my CloudStack agent is installed, my KVM things and libvirt, everything is already there. So I'm actually going now to continue with the next section. We need to configure KVM. So we need to actually configure QEMU and libvirt on two places. I'm going to open these files and effectively uncomment listen line. This is also installed. Right, so I'm going to search for the word listen. I'm going to find this line over here, and I'm just going to uncomment it. Optionally, you can just add that whole line at the bottom of the file. I'm saving the changes and exiting on one host, and I'm doing the same on the other host. I'm basically commenting out this line, saving the changes and exiting the file. Next, we have also our /etc libvirtconf. Now this is many lines, well, not many, but quite a few lines to be able to manually search for them. So I'm actually going to the end of the file and just paste those. Actually, let me turn the second one as well. Right, so I'm going to paste these lines as needed. Save the file, exit. On the second host, I will repeat the same, save the file, and exit. We are almost there. We also need to configure the Sys Config libvirt file, comment a single line. That's the libvirt args -- listen. That's the one we need to uncomment. So I'm just uncommenting this line, as you can see, saving the file, exiting, and doing the same over here. All right, just a second. Saving the file, exiting, and finally I can restart my libvirt on both nodes. So all these changes are actually applied. For the sake of completeness, you can do the ls mod and have your KVM modules loaded for your CPU. I'm running Intel, as you can see. These hosts are on the VMware hosts, which are actually running on top of Intel. So KVM_Intel is loaded. And this is almost it when it comes to the KVM host configuration. Again, this is basic POC. Effectively, you will want to do further steps and tunings and this and that on the OS level and additional security and everything, but this is the basics. So right now, if we actually check our network configuration, you can see I have two Ethernet interfaces. We basically, and this one is something that libvirt creates by default. You can ignore it. We don't need it, and we can actually delete it. So I have two, let's say, physical interfaces, but for CloudStack purposes, we need to create two bridges, Cloud Bridge 0, for example, and we will join Ethernet 0 to Cloud Bridge 0, and we also will create Cloud Bridge 1 and join Ethernet 1 into Cloud Bridge 1. For that purposes, we would want to edit the network configuration files, which on CentOS are located in this specific folder, /etc/sys config/network scripts. I'm going to go into that folder. And I'm going to quickly just list the files. So you can see we have these two network configuration files for our interfaces. And I actually need to edit these two to make them member of the bridge. And we also need to create bridge interface configuration files. Because I have actually prepared this in my notes to make it a bit quicker. So I'm going to edit the if fcg Ethernet 0 configuration. I'm going to delete what's already there. You can actually see that my interface is taking its IP via DHCP. So we are effectively, or we need to move the IP configuration from the Ethernet interface to the bridge interface. That's something we'll do on the bridge. But for now, let me paste my Ethernet configuration file. It's pretty much the same with the exception that we say it belongs to bridge cloud BR0, cloud bridge 0. There is no protocol for IPs because we are not getting IP or not setting IP configuration anymore on the Ethernet interface. We are setting it on the bridge interface. So I'm going to save this one. I'm going to do the same on the second host. Delete everything, paste my, sorry for that, paste my configuration, exit and save the changes. Now I'm going to do the similar things for Ethernet 1, and then we are going to do the bridges. So for Ethernet 1, it's slightly different. You can see that currently it's also by default, you know, when you install CentOS, you can choose that it's also gets its IP via DHCP, but actually this is used only for guest and public traffic. I do not need IP address, nor I actually have it at the moment. So we are not actually moving our IP configuration from Ethernet because we don't have it. We are not moving it because we don't need it. We are completely removing it, the IP configuration from both Ethernet and bridge interface. So here I'm going to delete the content of the file on both nodes, and I'm going to actually paste the proper content. This is very minimal configuration. You can see the device Ethernet 1. Yes, it should be started on boot. No protocol, it's type Ethernet, and it's member of the bridge cloud BR1, which we will create. It doesn't exist yet. So let me do the same on the second node, save the changes on the first node, and I'm done with editing my Ethernet configuration file. Now we want to create from scratch, obviously, Ethernet configuration file for our bridge. Cloud BR0 is the bridge that we want to create. So Cloud BR0 and Cloud BR1. So I'm going to hit enter over here, and I'm going to basically create this file on both nodes. Here comes the content of the Cloud BR0. The device is named Cloud BR0. The type of device is bridge. Yes, we want to start it on boot. It should be getting its DHCP parameters. This is the first bridge of for the Ethernet 0, let's say, to which the Ethernet 0 is joined. So yes, we want to get the IP parameters on the bridge now. Some IPv6 which want to disable, and all the other are pretty standard things, nothing let's say too fancy. So I'm going to do the same on the second node, save the file, and now we are done with creating the configuration file for Ethernet bridge 0. I'm going now to do the necessary configuration or create a configuration file for the Cloud BR1 on both hosts, and here comes the content for that one. So again, name of the device is bridge on boot. Yes, the difference is that we don't need IP configuration at all because we're just doing trunk of bridge. No IP is actually needed, and I'm going to just save the configuration file here and over here on the second host. And I'm going to now well, I'm now basically done with my Ethernet configuration file changes. You can see we have effectively two Ethernet files. Ethernet 1 will be joined to bridge 1, Ethernet 0 to bridge 0, and Ethernet 1 to bridge 1. If you now examine with a brctl show or some other command you like the bridge setup, you will notice we think this is a default bridge which you get when you install libvirt, something you don't need, you can remove in virsh, so you can ignore it like it doesn't exist. So there is actually no bridge, nothing. I'm now going to do the systemctl. Actually, no, I'm going to first disable the network manager, which is something that is actually mentioned here in the guide. Let me just find it. So it's actually easy for me to be lazy and copy paste. So I'm disabling the network manager. This is something, this is evil thing that you definitely want to disable. You want to enable the network service on both KVM hosts, and you actually want to restart the network because we have done the required changes here with Ethernet file and bridge files. We want to now apply these changes. So here goes brctl show before we apply the changes. Now I'm going to do the systemctl restart network on this one, and let me repeat the same. On the other hypervisor. So I'm just going to copy everything over here. Oh, no, I have already done that, sorry. And network service as well. All right, good. So let's restart network service on both hypervisors, and let's actually check now the bridge configuration. If I do the brctl show, you can see I have my Ethernet 0 joined to Cloud Bridge 0 and Ethernet 1 joined to Cloud Bridge 1. If you do the if config, actually, you can see that our Cloud Bridge interface is just a normal thing when you actually move your join your physical interface to the bridge. The bridge member does not have, obviously, the IP configuration. And then again, Cloud BR0, we said we don't need IP configuration either there or obviously not on Ethernet 1. The same is true for this one. We can quickly show that everything is in place. So we can do the if config, and you are good to go. You have your bridges and Ethernet configuration interfaces done. Now, we have finished our configuration, both operating system, hypervisor level, and network level configuration of our KVM nodes. So it's now actually time to go into CloudStack and configure it. So if I go to my management server, let's just observe actually that this system VM template script has finished. It says successful installed system VM template to this specific mount point. So this is actually the path on the secondary storage. Obviously, we go first to the mount point, and then this is the actual path where the template is supposed to be installed. Now, you don't necessarily have to, but I will unmount my temporarily mount location, which is /export/secondary, because we just needed it temporarily to effectively write the template into our secondary storage, right? So that's it. If I check the IP address of my server, let's imagine I don't know it. That's actually this IP address over here. So we are going to port 8080/client. This is the default URL for the CloudStack management server. I'm going to log in with the default credentials of admin and password, something you obviously want to change so that some people at your corporate do not actually access your cloud and mess with it. But yeah, before we do our zone configuration, so just to say, we can hit the button key, basically continue with the installation. Here it will force you to change the password. I actually don't want that. So I'm just going to go to my infrastructure and zones, and I'm going to actually add a zone which will invoke the same wizard that you would otherwise have if you clicked that originally shown button. But before I show you this, I just want to show you this, the output on the KVM host of the network, because networking will be now changing after on KVM host, just to show you a couple of things. BRCTL will show you that we just have a bridge with the physical interfaces there. So if I go back to my presentation, my next slide is showing that here on the left is one KVM host, and here on the right is another KVM host. So you basically saw this picture in a different way through the high-level physical, let's say, scheme previously on my previous slides, but this is how it looks from the inside of the KVM host. Basically, we have our physical Ethernet 0, which is member of the Cloud Bridge 0, and this Ethernet 0 is connected basically to the wire, let's say. And we also have our Ethernet 1 later. These are the VLANs which will be going through that second switch. If you remember that, or first or second actually picture with two switches, the diagram with two switches, this is basically the second one, this is the third one. I'll go back to this screen. I'll go back to this screen soon. Let me go back to my terminal and UI. So here, advanced network without security groups. I want to give my zone name. I'm not using very creative, obviously, names over here. Now, this is the let's say public DNS, so I can use Google one. I also have internal DNS set on my network, which I'm going to set over here. Hypervisor, we want to go with KVM, and there is this guest CIDR. So when you are creating what's known as simple isolated networks in CloudStack, you have the option to obviously define the CIDR range when you create each tenant network, or when each tenant creates its own isolated network. If you don't specify those parameters during network creation, then these default, or actually this default CIDR will be used. So this is just a default. Hopefully should be, we should actually say default guest CIDR. And that's pretty much it, what I need over here. I will not configure anything IPv6, obviously, and I'm just going to hit enter. Now, if you go back to our slide over here, we have two bridges which are connected to different physical networks. So for that matter, I want to configure two physical networks in CloudStack. I'm going to create two. The first one we can call, this is arbitrary naming, management plus storage. The other one is guest plus public. On this network, we are only creating, or this network, physical network, we are going to use to carry only the management traffic. So I'm going to remove guest and public. And storage is also implicitly happening over the management network when you don't explicitly configure it, which is my case. And I want to actually have my guest and public VLANs and that traffic on this second physical network. Again, this corresponds to the second physical network because I have two set of switches, or set of two switches for that matter. So let's actually add a public traffic type, and let's add a guest traffic type. Now, this is the time where a lot of people will fail or actually skip an extremely important step, which will actually render your networking not operational. So how does CloudStack knows that the management storage should be on my Cloud Bridge 0 and the guest and public should be on Cloud Bridge 0? That's a valid question that you should ask yourself. How should you tell CloudStack which Cloud Bridge to use for which purposes? Well, that's what you do with these traffic labels. It's not very visible. So you do want to set the name of the bridge. So I'm just going to copy my name of the bridge. I'm actually telling CloudStack on top of which bridge to create management, or to which bridge is actually handling, in my case, management traffic. For the public one and the guest, we are creating it on top of the Cloud Bridge 1. I'm using actually a bit wrong terminology, on top. It's not actually created on top, but I'll explain later. It is using this bridge for the things. So I'm now good to go. I have my two physical networks, what we call physical networks in CloudStack. Both are using VLAN as the isolation method. I have configured my KVM traffic label, which is an extremely important step. Otherwise, these two would be created probably on the first one. things won't work. So I'm going to hit next. I'm going to define my public IP range. Now, as I told you and showed you on the slides, I already have all this planned out. So I'm going to now copy these things from my notes. Sorry. So I'm just feeding now the input information that I have already prepared in my notes to Cloud. So this is the range for the public network. You will notice this is actually not really publicly routable IP range, and it doesn't necessarily have to be unless you are configuring public cloud, which probably most of you will. So in that case, yes, you will want to use really publicly routable IP space. This is again private RFC 1980, if I recall correctly, the RFC document. So basically, this is the range which the CloudStack will use to assign IPs to the public side, the north side of the system VMs, secondary storage VM, console proxy VM, and all virtual routers. They will get IPs from this range. The idea over here is that I know that when a router with, for example, IP41 wants to reach internet, it will send the packet to its default gateway. And in my case, I do know that this is further configured properly to route traffic to the internet. So I can actually really go and download things from the internet from the system VMs, which is actually I want to download, download a template and so on. Let's continue with pod creation. Again, I'm going to feed some information that I already have prepared, and I have also already showed you this on the slide. The reserved system gateway, this is the gateway that will be configured inside system VMs on the management network. In case you have multiple pods, your management server might be on one subnet, pod 1 could be on another subnet, pod number 2 will be on another subnet, pod number 3 will be on another subnet, and all of these pods and the management need to be routed in between. So you need to, for each pod, to define the gateway. In my case, this is not really relevant because I will not be using it. I have a single pod, but you do have to configure something. So I'm going to feed all the necessary information over here. The biggest problem when you configure CloudStack is to plan your networking properly. Everything else is really simple, but you do need to understand the requirements. And yeah, that's something that takes a bit of, let's say, experience and investigation. But once you have all the parameters, you are good to go. Now, this is, as it says, guest traffic. So I know that I'm actually will be giving a set of 20 VLANs to my zone, so it can actually create tenant networks from these VLANs. Cluster, I'm going to give not really friendly name of cluster 1. And finally, we need to add a first host, primary and secondary storage. So my first host is on the IP, if I do the if config over here, is on the IP 1032.185, and I'm going to add this one, and I'm going to provide root credentials so that CloudStack can actually connect via SSH. And it will actually configure CloudStack agent, after which the communication will only happen through the CloudStack agent and not anymore through the SSH. So I'm going to hit next over here, and I finally, or almost finally, have to configure my primary and secondary storage. Both my primary and secondary storage are from the same server. I will give it name, again, not very descriptive. The scope is if you have multiple clusters, whether you want the single primary storage to be consumed by all the clusters in a zone, then you would set the scope to zone, but I have only one cluster, so I can actually do it either way for that matter, but let's go a storage per cluster. I'm going NFS, I'm defining my NFS server, and I'm defining my export path, NFS export path or export NFS share in my in this actually dialog. I'm going to hit enter, and I'm going to do the same for the secondary storage. We are using NFS, which is what 99.99% of the installations will use. Very rarely somebody will actually use S3 or Swift. Name secondary 1. Server again is the same one as I used previously, and the path I know from my notes is this one. So this is my secondary, let's say, export share. I'm going to click next. And assuming that I didn't make any mistake, any typos, that I have the proper connectivity to the KVM host, proper connectivity from KVM host to my NFS servers and so on, I should be able to have my zone up and running in, let's say, a minute or two in my case. Now, in order to spare some time and not wait for this and sit in silence with you, I'm going to quickly go back to the slide until this wizard finishes. So, this is what you have configured manually with S2 physical network interfaces and 2 bridges in your CloudStack, in your KVM host. And this is how the networking between those hosts looks, or at least the connectivity part. When you, for example, create VPC, which will automatically create a virtual router for you, you will have CloudStack behave in the following way. You remember we defined Cloud Bridge 1 as the name for the traffic label for public and guest traffic. So what CloudStack will do, it will say, all right, I should be using Cloud Bridge 1. Let me find out the child interface or the physical interface of that bridge, which is Ethernet 1, and it will learn that it's actually Ethernet 1. Then it will take the VLAN for the public network, in my case 51, the VLAN 51. It will create Ethernet 1.50LAN, a VLAN interface on top of Ethernet 1, and it will create a brand new bridge, actually, which you can see, bridge Ethernet 1-51. And all the system VMs on this specific host that should be basically, let's say, joined to this public network will have their virtual network card joined to this bridge. When they send the packet to the internet, it will go as a normal IP packet untagged to the bridge, go down to the Ethernet 1.51 VLAN interface, which will do the VLAN tagging. And then it will be physically sent over the Ethernet 1 interface via this red line. And from here, you can either communicate with the public IPs over there, or from here, you will have a connectivity to external gateway and actually go and reach internet. Let me just quickly go back and see if my zone is finished. It is indeed. So you can see there are no failures. Everything is up and running, or actually not up and running, but everything is successful. I will enable my zone. And that's pretty much it. On the system VMs, we will just basically see that we have effectively or will have very soon our system VMs up and running. Assuming my hosts are up and enabled, yes. I will skip a step of adding additional hosts. It's just a matter of host name, username, and password. That's the second KVM host because we are short on time. But here you can see my 2 system VMs are slowly starting. And while they're starting, just to briefly show you, this is when you create a virtual router. Now, once you create a first user VM, we are going to use some of the VLANs from the pool, in my case, 1521. So effectively, CloudStack will again learn the Ethernet 1 as a physical interface of Cloud Bridge 1. It will provision the VLAN interface, and it will provision a bridge to which it will join the virtual network card of the user VM and also of the guest virtual network card of the virtual router side of that user VM. So when the VM wants to communicate to internet, it will send the packet down the bridge to the router. Router will do the routing and then further forward the packet via the public network to the internet. And finally, if you deploy a VM on second host, the same thing will be provisioned over here so they can communicate via this blue line, basically. And in your environment, you will also have your system VM, secondary storage VM, and console proxy VM, effectively. So that's kind of a diagram that I want to show you. If we go back to our CloudStack, just refreshing, you will see, all right, I have made a misconfiguration, which is very unfortunate and embarrassing, but there you go. Your VMs should be up and running right now, and I think my time is actually almost up, right, Yvette?
Almost up, Andrea, and we have one question at the chat. So if you can wrap up, and then I will ask the questions.
All right, good. Yes. I think it's no point now troubleshooting because we have a couple of minutes. My host is up and running, but it seems that I have probably done something that is wrong, as it seems. Yeah, I guess that's it, Yvette. This is a very bad failure after a couple of times exercising it, but there you go, happens from time to time.
We have experience with these two options, Andrea. If you would like, you can continue in a room. I can open a room inside the conference platform so that you can continue and everybody who is here can join this room. It will be open in a few minutes after we finish the workshop. And Andrea will be waiting for you in the room. And now I'm going to the Q&A, starting with the first one. What is the best way to get the MySQL database redundant? Is Galera supported and or working with CloudStack?
All right, yeah, so for redundancy, you can use what I would like to call it old-fashioned, was previously called master-slave replication with a different terminology these days, obviously, lead and replica. So that's one thing that you can go about it. The other thing is indeed Galera Cluster. Now with Galera Cluster, you just need to make sure that you are sending MySQL writes only to a single node. Because of the what's called optimistic locking in Galera, there will be deadlocks happening if you try to do a load balanced writes across all three nodes. So you should be basically writing to only one node, but you can read from the three nodes, basically load balancing the reads. If you're brave enough, you can use some of the MySQL or MySQL proxies, which are meant for that purpose. Or if you want to keep it simple, actually, you might want to simply be using directly just the first Galera node from your database properties file, and then manually fail over in case of issues, which is probably much safer thing to do.
Thanks, Andrea. Going to next questions. Next one is coming from Venko Muyankov. Do you recommend using KEMU KVM EV from CentOS KEMU EV repo over the from the base repo in CentOS?
Yes, so definitely with the stock versions of the KEMU, basically Red Hat has removed support for the online storage migration, so you cannot do a block level copy if you want to migrate from one storage pool to another with moving the actual disk data. You're not able to do that. You can use the KVM KEMU EV from the CentOS KEMU EV repo, but even that one, at least up to version 2.12 did not work because it didn't support it, but you can use the same one from the OVIRT repo, which is also Red Hat provided repo. That one does indeed provide a live storage migration. So yes, KEMU EV is probably a better way to go over the stock versions of the CentOS.
And according to you, Andrea, which distro is good to run the CloudStack effectively in production?
Well, most of our customers will still advise to use CentOS 7 because CentOS 8 is something that's being basically dropped as a project completely, obviously, and we do now support other operating systems, but definitely CentOS 7 is a way to go, or Ubuntu 20 is also something that's very stable and good.
Thanks, Andrea. We're really running out of time, and I see that there is one more question from Damien, but I will open the room inside the conference platform. So please, everyone, in maybe not more than 5 minutes, you will be able to join the room. So yeah, let's move there. And thank you, Andrea, for the nice workshop.
Thank you, guys. Thanks for that.